Hello, and welcome to EURAXA Smart Talks.
The Smart Talks podcast series is an EU-funded EURAXA project which provides information and assistance to researchers at any career stage.
EURAXA support the EU research area in its ambition to create a single borderless market for research, innovation and technology in the EU.
We support researchers in mobility, careers within and outside academia, innovation and entrepreneurship.
We strive to increase scientific collaboration between Europe and the world.
Welcome to another episode of EURAXA Smart Talks, the podcast where we explore the journeys of researchers who are pushing the boundaries of knowledge and curiosity.
Today we're talking to you beyond the Earth, to the icy moons, dusty plains and hidden subsurface oceans of our solar system. Our guest is Professor Elena Pettinelli, a physicist, a planetary scientist from the University of Roma Tre, and the Principal Investigator of an ERC-funded SWIM project surfing radio waves to detect liquid water in the solar system.
Elena, thank you very much for joining us. Elena is not only a world-renowned researcher with publications in Nature and Science, but also the director of the master's program in science communication at Roma Tre. So she is one of those rare scientists who can translate the wonders of physics into stories we can all relate to.
We are going to be talking about her extraordinary story, and to start off, the title of your project, SWIM, Surfing Radio Waves for Liquid Water in the Solar System, sounds like something straight out of science fiction. Could you explain it to us, non-physicists? What does it mean? What are you doing?
Yes. What we are doing is we are using electromagnetic waves, the same waves we in some way produce using a cell phone. With these waves we can investigate inside the planets. We're basically doing like a scan, but using this kind of frequency, which is a radio waves like FM frequency in the megahertz. And this allows to create an image of what is inside. For example, under an icy crust, you can see the structure of the icy crust, and you can see every material that is under the crust, for example, water. So we're doing kind of this scan as a geophysicist, and so we can detect water. We can detect changes and boundaries in the subsurface. So every target that can tell us that how a planet, a shallow crust of a planet is formed or is evolving.
That sounds amazing.
Why this liquid water beyond the Earth is actually so important? Not just for scientists, but for all of us. And what are the bigger questions of research that helps you to answer?
As we know from biology, the organism, the bacteria, the simple forms develop in water. At least our experience on Earth is we think that there's no life without water. Water is extremely important for many processes. So what we are trying to do is trying to find in the solar system other planets or other satellites where the water exists, because this is the base, we think, for the life as we know it. So as a first step, when we explore a planet, we search for water. Once we find direct or indirect evidence of the presence of water, we're trying to look for chemistry that is an indication of development of possible development of life in that environment. So it's always the first step. That's why it's so important.
That sounds amazing. And talking about the environment, the basic output of your project is studying environments of different bodies in the solar system. How do you bring all the physics, astronomy, high tech together and keep your team motivated to do this work?
Well, first of all, I think that looking at the other planets or outside the Earth is always very fascinating for everybody. We are very attracted by it, look up and see also the moon or other things. Yes, there are many things that need to be known and controlled in terms of experimental conditions, the physics beyond. And all the technology you have to develop, but the group is extremely attracted by these issues and the idea of fine water or answer some fundamental questions about why we are the only one in the solar system that develop a structured life, and why not on other bodies. So the question of finding water is essential, is fascinating, and keep you working really steady on that issue.
And looking at this from a European perspective, how does your work fit into the larger European space and science community? What does it mean to contribute to this global exploration effort from Italy and from Europe? So you're collaborating with ESA constantly.
Yes, we are collaborating with ESA because ESA is making the mission, okay? Is building spacecraft, is building instruments and put up and launch a mission. It's ESA that is doing this. So we want to contribute to improve the knowledge and the visibility of ESA, and this is very important because we are supporting ESA missions. So especially for the Jupiter icy moon, there is JUICE, which is a large mission that is flying towards the satellites at this moment, and everything is going well. And we think that this project is very important to help some of the instruments that are on board, and especially the radar, RIME, the radar that will investigate the subsurface of Ganymede and Europa, to find the right targets and to help understand if there are the condition of habitability and water in these satellites. So it's a strong support for science in terms of ESA, but also science in Europe in general.
This is interesting because we hear so much about Mars. A lot of things about Mars. Mars is the closest planet to us. We need to explore Mars a little bit more, etc. And now you're talking about Jupiter, something beyond even.
Yeah, Mars has been the first step because we have been looking for water on the surface, because there are actually several aspects that are really linked to the past presence on the surface on Mars. So we know that the channels were a type of the geology that tell you that was built in water, that kind of rocks. There is ice in the subsurface. There are water probably at the poles under the ice. And that was the first step in looking for life beyond Earth. But the so-called ocean worlds, so all the satellites that are beyond the ice line, so beyond Mars, are really interested because they really have the conditions to have the possibility to develop life inside, because it's kind of a warm heart, okay, of the satellite. So there is a crust. It's very cold outside, but it's very warm inside. And probably these nice salty oceans, so we think are inside the crust, are really a good environment for development of life.
But in case they are on this mission, so probably could I assume that your experiments could shed the light on what we see, if it is the water, what kind of water it is, and if there is a life in it also, like at least someone that we can expect maybe.
Yeah, no, what we would like to do is support the interpretation, especially of JUICE, to be sure that what is seeing is water, okay? In all this use of experimental instruments from a spacecraft, there are some uncertainties, of course. It's always in science. There is in science this uncertainty in measurements, but we would like to reduce this uncertainty because there have been a big discussion about what we've seen with the radar on Mars. And we want to be sure that now, with the background physics that we are developing with the SWIM project, we know exactly that what we are seeing is water, not something else. This is a very important step.
Mm-hmm.
Another question from someone who isn't in the field. Probes are more expensive, more difficult, because what you're saying, doing it with radio waves, is highly impressive, but can it be done in some other ways also?
Yeah, well, to look for liquid water so deep, maybe there are other geophysics techniques that can be done, but you need someone that put the instrument there. It's very difficult to do from far, from a spacecraft that is orbiting, to look for water inside. So that is an elective instrument. It's really important to use the radar in that. So it's difficult to think about something else unless you have an astronaut that can put a seismometer or something like that, which I think is
now that
difficult.
sounds like a sci-fi movie.
Yeah, that's you're going more on science fiction here.
I love Star Trek, so this is like a treat to me.
So yeah.
That is a very excellent and interesting explanation of your project, of the cosmic part of your studies. We are also interested in your personal perspective, in your development as a researcher, and most researchers do speak about their mentors, the first steps they took in research. Can you emphasize any turning points you had, any important moments in your development as a professor, as a full researcher?
Yeah, I have to be honest. When I finished my degree, it wasn't clear where I was going. Okay, I decided to do apply for a PhD because I definitely like to study. I really like that, and I was curious about some things. And definitely, everybody has mentors. Okay, we learn a lot from other people, and it's the right way. They are sometimes very fascinating figures inside the university. They can push your limits, okay, help to push your limits beyond what you think it could be your something that you cannot really overcome easily. And yes, I had my professor in physics that it was really, I had an excellent relationship, also human relationship with this professor, and he was a physicist. He was back a physicist from the group of Amaldi, and Amaldi is a group from Fermi, so it's a really good school in physics. And he was pushing me to look beyond what could be my limits and looking at this career. And definitely he had an important role in my life, and our relationship really, I kept this relationship also for many years. He passed away several years ago, and sometimes I miss him because it was a wise person to go to talk to. I had other important people that inspire me. I have to be honest, there are people that inspire me here in Italy, there are people that inspire me when I went as a postdoc in Canada. I met a very, very good researcher, and they all built my ideas or being a researcher. So they had an important part in my life. In my career, definitely.
And did you know from the very start, because you said you like to study, that you wanted to be a scientist? Was physics the field you wanted to answer the questions, or did you have other ideas as well?
I like physics, but I like applied physics. I wanted to do something. I entered in my career thinking to be an astrophysicist, and then I I was looking around and I see that geophysics was an interesting issue. I like the issue or solving problem for Earth, you know, Earth problems. And I worked at the beginning as a seismologist for earthquakes. So that was an interesting issue. And then I changed during my PhD. I changed topic, but yes, I wanted to do a practical physics. I really like experimental part, so I like to stay in the lab, even if it's always a headache because nothing is working. Okay, so but that's the challenge.
But at least to understand why it is not working is also a very great result, I would say, that we all need to strive for it. But in like the field is quite demanding, and you are a woman in like very man-like field. How would you describe your past? Was there any challenges in this field, because it's heavily like man field, because maybe we are perceiving physicists and the image that comes to our mind is not a woman in the lab.
No, this is true, but things are changing. And when I was studying, we were a number of girls in the School of Physics in Rome. I never had this felt myself that it was a limitation to be a woman, but probably because I found a good environment locally, a good environment. It's not always like that, I have to be honest, because there is still a certain prejudice towards the ability of girls. And I have to be honest, when now that I'm a full professor, I really enjoy the fact that there's girls are coming to do the thesis or studying physics, but they're incredibly reliable. So I have girls in the lab are fantastic. They are good, they're reliable, they know what to do, they have ideas, and so I think it's a good opportunity to help other women to see in the perspective of nothing is missing to be a very excellent researcher. So I really enjoy, and in fact part of my group, there is a good part of my group that are girls and women.
So you are gender balanced.
Yes, definitely. Definitely. Maybe we are also a little bit on the other side.
Yes, see? Okay.
You're also deeply involved in science communication. You're the director for your master's program. How did this come to be? And how does it empower your research now? How do you apply it when you are working in the laboratory?
The idea of the master came from many experience we had here in Roma Tre, especially in the physics course, to try to involve the people, the citizen, and students in looking at science as something that is enjoyable and fun. And so we had lots of cases where we could develop seminars or days where we were showing to the people experiments or talks or looking at inside the telescope, or all these things are fun. And we had many years of this kind of experience in science communication before thinking to starting a master program of 1 year. So, and that was done combining the experience of researchers. There are several researchers here, very good communicators, and some people that work in science communication in the university. And so combining these two parts, we developed this master. And the idea that also help the researchers that are not always good communicators, unfortunately, but they should be, because I think it's important to explain your taxes, where it's going. Taxes are going in pay also research. Why is so important, public fundings and this kind of stuff. And so we would like, we thought about this master thinking about young communicators, because there is an interest in people are graduating in STEM, but not only STEM, also in other courses, teachers, because they can become better teachers, more interesting in terms of science, and also researchers. Researchers need to be pushed to be better communicators. It's really important. And so we thought about this master, and we involve several teachers here, and also expert in communication, like journalists or TV shows, this kind of stuff, to show how this kind of program can be of certain interest, also for a new type of career. So you can have a degree, I don't know, in physics or in chemistry, and maybe you can think about to be a good science communicator.
There are some cases, by the way, which I know that a person has PhD in physics and did masters in science communication. But the trickiest part, I would say, is the balance, because the field is demanding. You should have at least some knowledge to understand what we are talking about.
Yes.
So the question is, where do you think the education ends and begins communication? Sorry for this
It's a
question.
very difficult question to answer. Well, in some way I see communication as a form of education, in the sense that I can always answer if I am in a class with a bunch of physics students. I can use a certain approach, of course, which is very formal and quantitative. And can I explain the same problem to a person who doesn't have a degree
Yes.
in physics? This is the important question. And this is the step from education where in some ways it's almost easier, because you talk the mathematical language and it's easier in this way. But thinking about to explain exactly the same thing to a person that doesn't have the degree, is you have to make a step towards learn how to explain the same thing taking the math away, which is extremely complicated.
Exactly.
But
challenging.
Yeah, it's very challenging, but I think it can be done. I think that everything can be explained to a certain level, as long as you make the effort. So it's the communicator, the teacher has to make all the effort to pass from something that is formal to something that is informal but correct, rigorous in any case, but
very hard balance.
Yes, it is. It is. It's a big challenge, but it's very motivating sometimes.
All the projects actually now demand science communication. Everything should be communicated, and we cannot focus only on the results, because until we get the results, we already lost everything, every connection with these people. So we should communicate about the process as well, about our challenges, also very important, I would say, and because people should understand that this is not only success stories. This is a lot of failures, which teaches us how to proceed, and this is what makes actually you a great scientist, because you still proceed, not being very devastating in your feelings that I didn't get the result that I was intended, so I quit. So applying for ERC, let's move to this, also one of the excellent part of our interview. Let's start with this decisive moment. So you have all this background, also science communication, so you decide to apply to ERC grant, and the grant is challenging as itself. It's advanced grant, you have to have high quality publications in high scientific journals. So how was it? How you decided? Was it one thing? Was you someone moved you towards it? Said, Elena, just take a look. Maybe there is a possibility for you, or what? What was your initial motivation?
I have a very peculiar story about the ERC. because I started thinking about ERC several years ago, okay? And I said, well, I heard about this thing. I really don't know what it is, okay? And so I decided to look at the winners of ERC in my field, and I wrote to a very nice gentleman. It's a professor in Germany that got the ERC in seismology. I said, well, I look at geophysics, okay? I wrote him and I said, listen, I have this idea to maybe, and I don't have any idea how I have to even write the project. Do you mind send me your project? Application, and he didn't. He sent me B1 and B2.
Oh my gosh.
It was fantastic. And I look at this thing and I said, I read carefully and I said, okay. I took this thing and I put in a drawer, okay, and I left there for several years, and said, well, maybe I will never apply. This is too difficult. But if I would try to apply, I have to have the right idea. I thought that was a very important issue. So in all my careers, I work on Mars. In the meantime, I publish these important papers and all these things. And at one point, we got involved in this mission to the icy moons, and the mission was launched in 2023. And I said, well, the mission is going. The launch was good. I have to try. I have some ideas. I know what is, according to me, is needed to do to maximize the results of that mission and to find the water, which I know is an important issue for these icy moons. So this is the right moment to take the
look at it again.
Yes, again, read again, and think about how I want to apply. Okay, so, and I spent several months to, of course, write this proposal, studying back several things. I was, in the past, I wrote a review paper on this issue, so I knew the literature quite well. So I said, well, this might be the right moment. Okay, it's timing. It's important and it's risky. I had some experience now in the lab that can be used, and so I applied for that. So I applied for that, I sent everything, and I almost forgot. I said, okay, who knows? And I got the letter. So it's I received this mail, and I didn't have the courage. My husband actually opened the mail and said, I don't have the courage to see what is. And they said, okay, we call you for the interview. And now the interview is almost another world.
Exactly.
It's almost another world, because I thought, so what I do? And what I do, I said, well, I want to prepare well. I don't know if I will never get that, but I've done the first step. I have to do well the second step. And so I contacted a bunch of Italians that won the ERC Advanced in the field. I applied in Science of the Universe. So it's a PE9. And so I contact some of the Italians that were abroad and say, well, guys, I have to do the interview. Can you help me? And some people won before the interview, because the interview was introduced for the advanced later, on a few years ago. And several gave me some really nice advice. I find the community of ERC winners very nice. And so they gave me some advice. And so I start preparing my presentation, which was 7 minutes. 7 minutes of presentation, and I thought, maybe I have to reduce in 6 minutes and 30 seconds because you are nervous at that time.
Yeah.
And so maybe you want an extra time. And I decided that to not be afraid to ask the opinion of my colleagues. So actually, I made the 24 version of my PowerPoint presentation, because I was preparing one and discussing with some some colleagues also not in the field of geophysics, but ask, I don't know, theoretical physicists how they were seeing the presentation, or other issue, particle physicists or geophysicists or whatever.
So build your own panel, actually.
Yeah, actually I was asking opinions of people about the presentation, and everybody was making some changes. So at the end I had to converge to a final version that I thought it was the best and would have the chance to explain to a large panel, because of course the panel you are in front are expert. Mine was, I don't know, relative theory, the other one was astrophysics, the one was planets, so it was very, very wide, and I thought, well, maybe after I heard the advice or the comments of people, maybe I can converge to this. And I prepare, and I fit in exactly 6 minutes and 30 seconds, and then I had 23 minutes of very important intense questions. And after I finished that, I said, okay, if I pass, I pass. If I don't pass, I'm not going to do it anymore next year, because it's stressful. I have to be honest. It's stressful, but can be done. I mean, the point is, don't be stubborn in your vision. So trying to catch the advices of other people, because the people see you from external point of view. You think you have wrote your paper, you know, and everything, but you don't know how to explain to a large panel what you want to do in a clear way.
Yes, exactly.
And you have to listen to the advice of people that they seem the critic. It's a critic, but it's not the critic. It's they are helping.
It's
They're really
contribution.
Helping. It's a contribution.
Yeah.
So I wasn't too arrogant in thinking that I knew everything and the other people couldn't touch the project.
Were there any unexpected questions? Like something that you, because 23 minutes, let's be honest, for such kind of questions on such thematics, it's not too much. I understand that it is intense, but it's not something, it's not 1 hour and a half when you can explain thoroughly, address the considerations, etc. This is super tight. No. Show-like performance. Actually, there weren't too many unexpected, because with all these interviews that I was doing with colleagues, I wrote down all the questions they were asking. Yes, and I was trying very calm to trying to think about the question and answer to the question. So I arrived very, very well prepared, in the sense that large part of the question were asked by other people. Mm-hmm. So I was calm enough to answer in a short, because now you have to be concise and to the point, which is interesting, talking about communication. You have to go on to the point very, very fast. So. Were there like questions about misunderstanding of something that you were saying, or questioning the methods or something like that? How it was in everything there was something in the method, something in the uncertainty I could calculate, something very specific in the lab, something about but you think you can solve these issues, or the space parameters is very large, which they are right. Yes, space parameters are very large in this case, so you can figure out something. So they were really to the point question, really well done, well thought points. Thank you to the panel. Yeah, exactly. It was really, really interesting. I think the whole process is very something that teaches you a lot. Yeah. To quit after if you fail from the first time. So it was the first try. The first try, and the first try, first hit, the first success. Is quite strange, because all the people I talked about, they were trying 2, 3, 4 times, or try. 4 times is approximate number. And this was the first hit, so it was lucky. Maybe you was on the edge. They saw it and decided, okay, let's not mess it up. Yeah.
And how did you getting the grant help you? Did it change your research, your team? Did it open up new perspectives, new opportunities for what you were doing?
Certainly, a grant like that and a project like that changed perspectives in the sense there are issues I was interested to investigate. But this gives you such a large possibility to address all the issue. It's not just money, it's not a question of money, it's thinking about what you want to do with that money in terms of developing your lab, developing your research, developing your modeling, and do like this. Certainly they give you an incredible possibility to solve some problem, address some questions. At the same time, you have lots of responsibilities. You got 3 millions, okay? My project was over 3 millions because I have extra instruments, and they give you lots of responsibility. You feel like, I promised to do this, I wanted to do that, okay? I might not succeed in some part. This is foreseen in the high risk, high gain of the project, but certainly I want to answer some question. Now I want to. So I want to work hard because I want to answer this question that I promised. So it's interesting, change your perspective in terms of the research.
And many of the researchers of our podcast are early stage researchers. So would you have some suggestions for them, maybe if they decide to apply? What are like the key takeaways from all this very difficult process that you came over?
Well, probably for them it will be a little bit easier because the approach of, for example, starting grant is a little different. I am start giving some seminar to young people to say don't be afraid to apply for ERC starting grant. I did some in my university and I got invited in other parts. I think they should consider seriously. There are several issues that are difficult to focus from outside. So you have an idea, you might have a good idea, and how to explain this good idea to other people in a clear manner that a committed thinks to fund you for that. Don't be worried about the criticisms from other people. This is for young people is important because they might be timid or they might be a little over-aggressive because they want to defend their ideas and have to be relaxed. And people, you have to discuss your project with people you think they want to give you good advice to help you improve. Take every critic well, okay? Don't get upset if the people tell you, oh, maybe you should do this and this and that, and don't afraid to try. Don't afraid to try even more than once because you have to develop some experience. Be ambitious, okay? The idea to be ambitious is important. If you are really motivated and you're ambitious, you can overcome some of the problems. Maybe you don't win the first time. Maybe you learn from the first time, and maybe you win the second or the third time. There's no problem in that, but I think they should, because there are lots of young, good, bright people. They should apply for that.
How to balance this high risk, high gain thing? What would be your advice? Because actually it looks like something as you are pitching to investor. People are trusting you and funding your project, and you are responsible for everything. So it is a little bit of too much stress for someone who is applying.
Yeah, no, this is what I was saying. Now I got the money, I feel responsible for that, you know. I want you to get good results for that.
Not too ambitious, but ambitious enough. What is it?
I think you have to be ambitious in terms of pushing a new part of research towards a certain direction. So you have to try something new, okay? Something new can give you some result. You don't have to be down if something is not working, because this is the problem. You try something and something is not working, and you feel depressed because it's not working. No, that's not a good approach. So you have to balance between the fact you're ambitious and you want to overcome a certain problem, but that problem will, of course, produce other questions and other problems. This is science, and so you have to balance your risk and your gain in these terms. You have to put in your project, in your mind, that you will fail in some stuff, but that's not the end of the world. As long as the failure teach you something and you can move towards another direction that is a better path to reach at the end the goal. So you have to work in this way. Mm-hmm. So if you think that the first failure you are lost, this is a problem. Okay.
Okay.
And talking about directions, in which direction do you believe that planetary investigations and research is going in the next 10 to 15 years?
I think we will consolidate some approach in investigating other planets. There are some satellites that are interesting to be investigated. So, for example, the area of Saturn is quite interesting for water and habitability. I think we will improve that part. Certainly there will be a big push towards the Moon and Mars again. Thinking about human exploration, which according to me is far ahead quite a bit. It's very challenging, especially for the fact that we are perfect to live on Earth. We are not really good to live outside. Yeah. To live outside. So there are important questions that should be answered in terms of safety of the astronauts that are not easy. Mm-hmm. Probably for the Moon can be addressed. In the sense, if you think of the Moon could be something like Antarctica. No, at the beginning of the 20th century, yes. Yeah, of the 20th century, exploration of Antarctica was terrible. The people were going in some conditions with a tent or something. Now they are nice, center for research. So it's a good area for research. There's a nice agreement about among countries that nobody can use, and you have to keep clean Antarctica. Yes. From that. It would be nice if we could reach this point for the Moon, and they might think something similar, so a base for science exploration, because you can do some interesting science on the Moon. So this is probably the thing that can be addressed.
And this is interesting because we had an episode with Frank Dennessy a couple of months ago, and his closing statement is somewhat similar to yours. So you both have a similar vision for where science exploration is going to in the future.
Oh, okay.
But, yeah. He's more on the intelligence side, but still also we were talking about the space stuff. And so I've seen some projects previously in 20th century that were thinking about the Moon as a station to the furthest planet, so not the Earth but the Moon. So we are now somewhere about approximately there, or somewhere further. What do you think?
No, I think that the first step would be the Moon, because thinking about Mars is it's very demanding.
Complicated.
It's complicated. It's really complicated. It might be in the future. There are many things that for us were complicated and not possible, and now we do it. In any case, I would say that space exploration is a very important issue in terms of some understanding of science, because one of the questions I always had when do seminars for citizen scientists or public outreach, this kind of stuff. They ask you why you spend so much money on planetary exploration.
Exactly.
This is no, and there are lots of things that we gain from that. Let's talk one moment from the astronaut point of view. Many of the things we know about aging, we know from studying what happens to the astronauts. For example, for the bones. No, the fact the bones, the muscles that reduce in absence of gravity, or what happens to the heart, what happens to the pressure, all these things. We learn a lot from studying the astronaut conditions, especially now that the astronauts are really in good condition, they are really well monitored and stuff like so. Lots of things we are learning from that. This is what happened to the astronauts that stay in space with no gravity. It's basically a fast aging that they can recover when they come back. This is a very interesting point. Okay, that we learn.
They can recover.
They can recover.
Okay.
But we learn what happens if you don't exercise, if you don't have, muscular activity or stuff like that, or this kind of stuff. So this is really, really, really interesting for medicine. The other point is when we build a mission, we spend a lot of money, but we develop techniques, instruments, materials, lots of things that I don't know if we'll put the money to investigate or develop. So lots of things we learn from space exploration. If you think that the solar panels were installed before the 1960 on the spacecraft, the small spacecraft of the Soviet or the American. So solar panels were back there. Communication things, they all come from also space. There are lots of materials, and nobody knows that battery tools. The first drill was built by Black & Decker for the astronauts on the moon, because they had to take samples and how they excavated the rock. So they built the first battery operated. So there is so many things in our life that they never think about, that they come from space exploration. So there is a large benefit from that. So, and in any case, investigate space, investigate other planets. For example, I don't know, if you investigate Venus, you learn about greenhouse effect much more. So you learn something useful, maybe useful, I hope, for the Earth. Investigating Mars, investigating Venus, investigating the ice, because you learn how to investigate the ice on the Earth. So there is a lots of these things.
May I ask one particular question? But in your study you explore planets and the water on planets. What about the asteroids? It is not asteroids, meteorites. Do you see them as a potential?
Asteroids are investigated with the similar techniques. There are missions. So there is also an ESA mission on one asteroid, so that is going now. Asteroids are investigated for mainly two things: understand better the formation of the solar system. This is important, especially asteroids and comets, to understand where water was coming on Earth, or how come we have all this water, where it's coming from, etc. And the other things is we can mine this, which is a more let's say
even more challenging
than
everything what we described.
But if there is something special, materials that can be mined, excavated there, that is not easy to find here. There are these issues, okay, in terms of mining these small objects. So I see from much more from the science point of view than the using of the material anyway.
Do you happen to feel same as I do right now, that I have even more questions than answers? How you how you deal with this anxiety, I would say. Like, the farther we are from Earth, as if it gives us the more understanding of how it is actually working here, and how it is not working here also. And then when we return, when we understand the results and summarize what would be like your things, what you expect to happen in 5 years when you are finalizing. So you deliver the results. What are they?
Well, I will expect to answer some basic questions,
Okay.
and I expect lots of more questions.
Yeah.
Of course, I think it will be a little bit more refined and maybe a higher order questions in terms of very basic questions. I hope that we can answer some important questions to try to find the water. Yes, I will remain with lots of more questions, which is the work that I will do in the next few years, probably.
Okay, Elena, thank you very much for the interview. It was really interesting and encouraging. It was full of different contents. We are definitely pasting also the addresses and links to your project, and we will also would like to have a follow-up on your results.
Okay,
I will have a good luck with that.
Thank you very much.
Thank you.
Thank you for listening to this episode of the ERC Smart Talks podcast.
We hope that you enjoyed this episode and can't wait to share more with you next time.
You can follow us and find more episodes on the ERC portal, our social media profiles, or wherever you listen to podcasts.
This episode was prepared by hosts Daria Aksionova and Jovan Arangelovich, editor ERC, and is dedicated in memoriam of Professor Miroslav Trajanovic.